Hello, my friends. Today's video is on partitioning a segment. To partition a segment is just a fancy way of saying that we want to split a segment into some sort of fractional parts. If we take a look at our first example here, we're looking at a number line. And we have a segment on here, AB. So A is at -5, the other endpoint B is at 10, and we are challenged to determine the point 2/3 of the length of AB. So let's first find the length of AB. If we're going from -5 to 10 on the number line, that is a length of 15 units. So if we want to figure out what 2/3 of that length is, that just means we have to multiply 15 by 2/3. So 2/3 of 15 is 10. So let's go back to our number line. That just means we need now a length of 10. If I start at A and move out 10 units, that brings me to +5. So +5 would make a segment here that over to A that is 2/3 of the length of the whole segment AB. Going the other way, if we go from point B over towards point A, again, our 10 units, 2/3 of the length, that would bring us out to the point 0. So we have two solutions here only because we weren't told whether we should start at A or we should start at B. We just were challenged to find a point that represented 2/3 of the length. So two solutions here. In the next example, we're looking at something a little bit more specific where you're given a segment AB and you're challenged to locate a point C such that AC is 1/4 the length of AB, the total length. So we're going to take a look at the idea of slope here. I put that as step number 1 is to find the slope. Now we're not looking to find the ratio of the rise to the run, which is really what slope is. We just literally want to know the rise and the run. So if we think about horizontal and vertical length, if I'm talking about my change in y values, I have 5 minus -3. So double negatives make a positive. We have a length of 8 here. Considering we're going in a downward direction, I'm just going to actually change that to a -8 to represent the negative slope. We are decreasing y values. For the x values, we're going from -4 to 2. Remembering that we need to think about absolute value here as distance is always going to be positive. So going from left to right, we're moving 6 units. So once we've determined the rise and the run, we need to go back to the question where we're looking for 1/4 of the length. So we're not actually going to be running 6 units. We need to run 1/4 of that amount. So 1/4 of 6 is 1.5. Our rise, if you recall, was the -8. So again, we're not going to be rising a whole -8. We just need 1/4 of that amount. So 1/4 of -8 will give us -2. So now let's bring this all back together. The question asked us specifically, we wanted to create a segment AC, which means we had to start at A and go out to a point C that we have to determine the location of. So our change in our x values was that we went +1.5 from point A. Our change in our y values is we went -2 from point A. And when I combine these, I'm going to get the location of my point C. So -2.5, 3. So let's take a look at that location on our coordinate plane. So -2.5, 3 is my final answer. So -2.5, I'll go up to 3, and I'll create my point here. Now let's take a look at that whole 1/4 piece just so that we can really understand what that means. If I use the highlight tool here and we look at this segment that just got created, AC, right? So that means if this length is 1/4 of the full length of the segment, then that means if I take this portion here that I just found, I don't want my rise. Go away, little part. All I'm looking for is this part right here. So if I copy and paste it, look at how many times, right? 1/4. I'm going to stagger them to make it a little easier to see. There's 2 parts, there's 3 parts, and there's 4 parts to my segment. So yes, it does take 1/4, right, of the length of the full segment to get to the portion of C that we were looking for. So I hope this video was helpful, and I will see you next time.